yesterday.
We almost hit my car.
Yeah, guess who was
What? You were like turning this way and you like took forever to turn. What is this guy doing?
But did you do what Mr. Olsen did and think to yourself,
No, I was like, why is
you
he?
have an epiphany?
I was like, why is it taking so long to turn?
Yeah, you don't even have
I thought I did.
You said air
No.
My parking was not good.
Hey, maybe Trav.
I'm glad you didn't say anything. It's his birthday. If you like, tell him his parking's bad on his birthday.
Yeah, it was. I don't think you understand. But I think he was running a little late.
This was, okay, Mr.
I did it for us. You don't remember
What movie?
He's also in Now You See.
Isn't he Oz the Great Power?
Look how nice he looks.
Check you.
I use it 22 and what does he look like now?
He's like 40 now.
Yeah.
He's like 40. I thought you were drawing a smiley face at first. I was like,
He's 25 and better. He just has a mustache. I literally looks insane.
He's in 22 for Trav.
he's probably like 42.
What's going on?
Okay, guys. So let's look at 11 together. So you guys, for these problems, we need a common denominator. And so we want the bottoms to look the same. So if they're not the same, we want to try to manipulate them so they would be the same. In this case, hopefully you notice that this can be factored over here. X squared can be x times x, multiply to get 4, add to get 4, so 2 and 2. So this one has x plus 2 twice. So that one means this one needs another x plus 2. So we can't get rid of the one on that one. So this becomes 5x plus 10 on top. The bottom I'm just going to leave. So now we have a common denominator of x plus 2 times x plus 2. Now we can add the tops of those fractions. So the 5x doesn't have anything to go with, but the 10 and 6 can go together, so that'll be 16. So 5x plus 16 will be the top. Just adding those. And then the bottom, you just bring the bottom over. And then that's it, because 5x plus 16 can't be factored at all. You can't simplify anything there, so you just leave it that way. All right, going to 22 then. Again, guys, if you didn't have this done, I'd suggest you guys do this with us. I know, but you're missing out on practice then if you don't go through it with us. Should be a 2. Okay. So I need a common denominator with the 3a, 7a, and 2a. So they all have an a. But the 3, 7, and 2 need a common denominator, a common multiple. So I basically have to find a multiple until they're all the same. So I think it's 42, because 3 times 2 is 6, and 6 and 7, their common multiple is 42. I don't think there's anything smaller that they both go into. So I'm going to make all the bottoms 42, A. So I have to figure out what am I doing to 3 to get 42. Multiplying it by, is it 12? 14? I think 14.
Yeah,
I mean, you're the teacher.
she's the math.
Well, you guys have calculators. I didn't have one in front of me. I don't trust you now. I don't trust anything you guys say.
It's 14.
Thank you. So I have to multiply the top by 14. So this becomes 70 up here. 42, 7a to become 42, multiplied by 6. I know that one. I don't need to ask you guys. So that's 12. And then this last one's going to be 21. So now I need to just add and subtract the tops. So it's going to be 70 minus 12 minus 21. So it'll be 37.
37.
And the bottom just stays as 42a.
I knew that.
And then 37 is a prime number, nothing goes into it. So that's as simplified as that one gets.
Perfect.
Alright, so 27. Again, we want the common denominators on the bottom. And hopefully you guys notice on the second fraction, that's factorable. X squared minus 9 is a difference of squares. So we're going to rewrite this one, as x minus 3, x plus 3. This is why factoring was so important last chapter, that those kind of come to you more easily. You're not like spending forever and having to look up your chart, so that you guys know that factor. But then this one is missing the x minus 3. So I have to do that to the top and the bottom. So this one becomes x squared minus 3x all over. Then I need to do x squared minus 3x minus 6x has to be minus 9x. Now, you can leave it this way. Otherwise, you might say, well, I can factor out an x here. But that's not going to be helpful at all in terms of canceling anything. So it's the same answer either way. Either one is fine. All right, 28. Why aren't you going through this with us? I need you to stay and listen. You didn't do the homework, so you need to follow along. I'm asking you to write these down so that you get the practice. All right, so 28. Now these both can't be factored, and we can't just say, well, I need to add like 5 to this to make it be the same. So essentially, whatever the other one has, the other one needs. So this one needs an x minus 2. This one needs an x plus 3. So we can distribute this in. It'll be 5x minus 10 here. Over here, we can distribute that in. It's going to be 2x plus 6. Now careful with this one. This might be where you guys went wrong. This minus sign applies to both of those. So it's minus both of these. So it's like you have to distribute that negative in. So it'll be 5x minus 2x is 3x. Negative 10 minus 6 is going to be a negative 16. And then nothing can be factored at all, so you can just leave it that way. And finally, 29 is another one that can be factored. Here can be factored. Now, a lot of times just looking ahead and like seeing what they have over here, that's kind of usually a pretty good indicator, hopefully, unless it's just a really horrible problem. It's m times m. I want to multiply to negative 20, add to negative 1. So plus 4, negative 5 will give me a negative 20, but then add to give me a negative 1. So I have the m plus 4 here, so that means I need the m minus 5. So I'm left with m plus 2m is 3m, minus 10. Nothing can be factored out. notes here. We're solving today, and then just so you guys know, tomorrow we're actually kind of going backwards, going back to that first section of the chapter that I said is going to be a little bit tougher. But that's really kind of all we're doing from this chapter, and then we'll come back from break and review for a few days.
Yeah.
And pass. Sorry, my first hour class came in asking if we're just watching movies this week because it's Christmas week. I said, sorry, math class.
No.
Oh, what a freshman way. No offense, Sarah.
I actually think they were sophomores, but whatever.
Oh.
Maybe not. I don't know. Maybe it was freshmen. I don't remember.
Who was your first class?
Well, it's geometry, so it's a mixture.
Oh, yeah.
But I do have a geometry class that's almost all sophomores, so but that's not a class.
I feel like our geometry class last year was like
It was what?
like all freshmen.
Kai's a back now.
Yes.
Was I in that class?
I don't know anymore.
I don't remember. I'll never come here and go see about the notes like the
Well, I was like, I was sitting by freshman last year. I sat by Becca.
Actually, I think the
You were
picture
not
you
in
came
my
up with
class.
my memories for today, Abby.
Me?
Yeah, I think it was today.
Oh my.
It was ask Abby questions.
For a person?
It said, "Come get a math lesson by Abby." Was this 2 years ago? This was 2 years ago.
Oh, I was
I wanna
like
see
a freshman. In a onesie. Dude,
And then that girl who she doesn't go here anymore.
Emma.
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 Oh, yeah.
And that's Ari.
Wasn't she like your cousin sort of?
Me? Oh, yeah. I was like, you me. No.
I mean, technically not anymore, but
Oh, it's through marriage.
yeah. And then it ended in divorce.
Isn't that baby your cousin though?
I do not like being fitted, but yeah.
There's a baby you don't like?
Yeah, he's like 7 now,
Oh.
and he swears more than I do.
Oh, geez.
What are you teaching?
Oh, he's like
Nothing.
7 now? I remember back when he was like 1.
So we went out to eat with my dad one day. Like, it was, over Thanksgiving weekend. We had dinner with my dad. And my dad hasn't been around my kids very much lately because of COVID. And my dad like said the F word. And we like looked at him and like the kids were like, it's okay, we hear that all the time. And then my dad like corrected himself and then used the S word in its place as like a fix. Like he was like, oh sorry, I've been around kids for a while. And then he was just like, yeah. My kids are both like, they're like, our friends swear.
But they don't?
I don't think so. We don't swear. Like, we don't swear. Like, they don't hear
That's a
us.
lie.
He really,
I've heard Mr. Donahue say it.
he really doesn't swear around our kids. I don't think. I don't hear him.
He dropped a weight and he said the F word.
Oh, really? Okay. So guys, so just a reminder, when a fraction equals a fraction, do you guys remember how to solve this?
No.
Cross
Oh
multiply.
my god, I started doing it the other way.
I know, I actually looked at yours and I was like, I swore you were the cross multiply girl. So cross multiply.
Caitlin, you're like, no.
Caitlin's like, no idea. I give up.
I know, I should have thought it. I knew it. I'm done with this.
It's just amazing, like.
This is even funny.
So we do cross multiply here because we have a fraction equaling a fraction, so we get to cross multiply. So typically we like cross multiplying because it's kind of like, oh, we finally get to cross multiply because I've been telling you guys no like the last 4 days of these.
Wouldn't you do the other way?
What other way?
Like making it the same?
You could make the denominators the same, yeah. So it would work to do that, and so like that is okay. Actually, I'll use that a little bit today in what we're doing. So if you guys didn't hear them, they said they made the denominators the same, and if the denominators are the same, you can just set the top equal to each other. That works as well. This is probably a little quicker though, I would think.
I got the answer already.
Cool.
Now I gotta see if it's right.
All right, so we distribute, and then I'm going to move the 5 over, the 5x.
Yeah, that's definitely not what I got.
Oh no. What'd you do?
I don't know.
Is it in a negative 40?
Yeah, it's a negative 40.
I'll do it, yeah.
So it was right. All right.
Negative 64.
Wait,
Yeah.
that's what I got.
Oh, good job. Then you tried it and it didn't work.
And then I got negative 12.
What do you mean? You put it,
How'd you get
I
negative 12?
put negative 64 minus 8 divided by 6. Oh, wait.
okay, that's that side, and then you put it on that side too. They should both be negative 12.
Oh, no. I was expecting to get negative 64 as the answer.
Oh, yeah.
That's why.
So yeah, guys, if you want to check your answer, you put this value, guys, stop talking, please. You put this value back in, and you check each of them, and each of the fractions should equal the same thing. So if you put negative 64 back in, it should work on either side. So we're going to talk about solving, and this is one of the methods. So this is considered cross-multiplying. This is one type. However, some of you guys were like, now that you've got common denominators, like why don't we just use common denominators all the time? We actually are going to use those quite a bit today. So if you like those, maybe that'll be something, I'll show you guys a couple different methods here today. So, all right. So there is going to be something brand new we're going to learn. It's something called excluded values. It's probably something you've never heard of before, or maybe never realized that you knew about. So the first type of problems we're going to do is just a fraction equaling a fraction. This is where we can cross multiply. Guys, can you stop talking, please? So the first type of problem is when we have two equal fractions, then we can cross multiply. So this is going to be the first method I'm going to suggest that you try.
Yes.
Now, I want to talk about these excluded values. They're basically values that don't work in the problem. And our book is going to ask about these excluded values. What kind of numbers do we not like to see when we're working with fractions?
Negatives.
I don't think negatives are bad.
Decimals.
Decimals? They're not great, but they work.
Exponents.
Where don't we want in a fraction?
Pen does.
What?
I'm running out of options here.
Oh, math.
Yeah, go ahead. Variable. You're like, I don't like seeing variables. There's something that can't happen in a fraction.
Zeros in the denominator.
0 in the denominator.
See?
So,
That's
I knew zero again.
so we cannot have a 0 in the denominator.
If you would have said slope, dude, I would have got it.
I don't know where that I was supposed to go.
What?
I put the dot for the I like way away from it. So we cannot have 0 in the denominator. Thank goodness for Tara. So,
Yeah.
I was going to get there. I just couldn't think.
Yeah, okay.
all right.
My brain was
So, it says to state any excluded values. Now, this might not apply at certain times, and then other times it's kind of good to know about this ahead of time. What would make there be a 0 in the denominator over here? Yeah, if you pick x as 1, so if this equals 0, so if x minus 1 equals 0, so if I got x equals 1, that would be a 0 in our denominator. We can't have this. So this would be considered an excluded value. Going to the problem, knowing x cannot equal 1, so we want to say x cannot equal 1. This is the way we want to write that. We don't want this to happen. So some of your questions today are going to ask you guys for the excluded values. This is what they're talking about. That's just good going into it, so that way we don't have to check our answer. Because if we get that as one of our answers, then we get to throw that out. We call it an extraneous solution, or we just cross it out and say it doesn't work. Because we can't have a 0 in the denominator. So at this point, we have a fraction equaling a fraction, so I would say to cross multiply. Now you might say I want to get common denominators, but if you look, the common denominators here are a little bit tougher, so I actually think cross multiplying is a little bit more straightforward in this case. However, this does require us to know some of our stuff from the last 3 chapters. I'm multiplying x minus 1 times x plus 1. And then I'm multiplying 4 times 12.
48.
So what do I do with that now? We have to do FOIL. Now this is a good one, it's a conjugate, we like that. So those middle 2 terms cancel out. Now here's choose your own adventure, choose whatever method you want. How do you guys want to solve this? Yeah, I would probably choose to solve this one by a square root because it says an x squared rather than factoring or doing something else. So I want to move this 1 over. So you can choose whatever method you want.
Hey now.
So then to solve that, we would take the square root, right?
Yeah.
And so what's our answer? And
49. Positive and negative.
we need both answers, both positive and negative 7. Now we want to think for a second, are both answers okay?
Yes.
Yeah, because neither of them are excluded answer. Now again, so Abby on the warm-up, she actually went and tested this. You could do the same thing over here. You should get the same outcome. Okay? So we need both solutions.
12
Okay.
times is the same thing, backwards.
All right. What's it?
Date
Oh.
is backwards. 1, 2, 2, 1, 2, 0, 2, 0.
Okay. So this next one, to talk about the excluded values again here. So what answers would not work?
0.
Very good. Excluded values. X cannot equal 0. Anything else? There's another one.
1.
Oh, actually, this other one's really hard to find.
1.
Give us a
1
hint.
squared minus 1 doesn't work.
2.
It's actually like the square root of 2, so that's a really bad excluded value. Sorry. It's because if I do x squared minus 2 can't equal 0, I move this 2 over, I get x squared equals 2, and I take the square root. So it's actually like the square root of 2. That's a bad one, sorry. I didn't think about that. So just a heads up real quick for the homework tonight. Some of them will ask for excluded values and then others won't. So I want them if they ask for it. If they don't, you don't have to worry about it.
You gotta read the directions.
Yeah. So at this point, we can cross multiply though because we have 2 equal fractions. Tougher one, just heads up. All right, so now this time, what do you guys want to do?
I don't know.
What do you think? Yeah, Ethan?
Subtract x squared from each side.
Yep. And hopefully you're noticing that this looks more like a quadratic that we might have to factor. We're not able to solve this one by square root because of that 10x there. So I'm going to move this over. Hey Ryan, can you close that up, please? So this is a tougher one. What kind of factoring do I want to do here? Yeah, that x factoring. There's no GCF, so this is a good review. We have to do this type of factoring.
Oh shoot.
Yeah, so that didn't go away altogether.
We should have said yes.
Sorry.
So, I'm like, yes, this is my favorite. I multiply the first and last. And then I have that negative 10x on the bottom. This will be a 10, not a 16. I want to multiply to negative 24, but add to negative 10. I think it's negative 12x and positive 2. I think 6 and 4 doesn't work because it needs to get to the negative 10. And one of them needs to be negative, one has to be positive.
Lindsay's right.
So I take this and I split this up as minus 12x plus 2x, but I leave the first and last term the same. So again, this is review from last chapter. So hopefully it's not too far out of what you guys remember.
I don't know.
Such confidence. So out of these first two, I can take out a 3x. Be left with x minus 4. Out of the second two, I can take out a 2. Be left with x minus 4. So I'm going to move this up over here. So I have x minus 4, and then 3x plus 2.
Yep.
To set each of those equal to 0. So x ends up being 4, which is okay because it's not one of our excluded values. And then a negative 2/3. Sorry, that's really poorly written. All right. Okay, yeah, we'll do a break. I think we should probably do a little bit of practice with this though. So I think I'll have you guys grab whiteboards if like this side of the room wants to grab them first, please.
My technical is
Yeah.
Jordan's giggling. That you're actually cheating the system right there. You're actually cheating the system right there. Cheating the system.
I don't know why you guys just don't wait. We're not in a huge hurry here.
Maddie? I'm sick of your attitude. Whoa. Thanks.
Draw a holiday character.
I've had it since seventh grade. What was
Holiday
that
characters.
Christmas one like? Winter calls or winter buddies or what is it? Santa buddies. Something like that.
Okay. I also drew something.
I have buddies though.
It's a gorilla. It's Bert the gorilla.
Yeah.
That's where I seen that.
Christmas gorilla.
That's neck.
I have a buddy.
Oh, he's cute.
Buddy Bill.
Okay.
It's Rick to all these people. That's not Rudolph.
Yes, it is.
That's Donner.
To make sure.
Yeah.
That's down and wearing a red nose.
Okay, let's try this one, guys. So solve this for x.
Hey now.
Solving for x.
Caitlin.
Yes, thank you. Thank you. Guys, on your board, please. Thank you. Thank you, both of you. Yes. Yeah. Yes. Yes.
I can't do this
Look at
math.
you. Yes. You're a little eraser. I know. You're so efficient. Yes. 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 Yes.
Kids, that
Oh, your Rudolph is cute.
Yeah, those are the back in the
I made my
middle.
own. Just grab your tissue. It works great.
Okay. So yeah, we have to cross multiply. So 7 times x minus 5 equals 6 times x plus 2. So this is 7x minus 35, and then 6x plus 12. We move the 6x over, so we get x minus 35 equals 12. And then we move the 35 over to get 47, right? And I saw a couple of you guys write the excluded values, so -2 and 5 would be the values that wouldn't make sense in this problem. Very good, Abby. All right.
Do you get it? You just did that now?
All right, let me
Is that
find.
the trident? Or no, that's the gum. Is that Sebastian? What's his name? Ariel's dad? No. What's Ariel's dad's name?
King Triton. It's Aaron's dad. It's not Aaron's dad. Oh, that was so funny.
I'm laughing so hard.
Sorry, I gotta find another one that's.
Abby, what? Why did you do that? I thought a middle schooler was Bella. Did I tell you this story? I thought a middle schooler was Bella, so I flipped them off. And I thought it was Bella. And I felt so bad because I knew it wasn't Bella. And I don't think they saw I flipped them off.
That's all.
I think it was Maya.
I'm trying to do my work now. It's quiet.
I'm
Okay,
drinking
try this
water.
one, guys.
Jordan, that's such a beautiful tissue on the back of your mouth. No, thanks. Oh, yeah.
Oh, when you move this over, you subtract it over. It should be -6. Oh, wait.
You're cheating.
Dude, this is close.
You're cheating.
Divide it wrong. Yes.
Oh, it's. Is it negative 2?
No. Yes.
You're cheating. You're cheating.
I just want to
I think you changed the problem. Set that word again. Yeah. Yes, yes, yes. Good job. Yeah.
Today when we were leaving AR.
Oh, I think you just wrote the calls down. wrong.
Today when we were leaving AR, I was the only one that dressed up as a
There you go.
character.
Good work.
And Mr. Wilton is a was like whoever dressed up for me, and it was only me, so I was like, yeah, suckers. I told
Okay.
you that.
So guys, in this case, distribute here, so I get a -4 minus 6x, and then this is 2 minus 3x. We need to bring the x's together, so I'm going to move this 6x over. And then I'm going to move the 2 over, which is a -6. And divide by 3, which then I get a -2. Let's do one more.
Where's Maddie? Is Slinger by West Bend?
Yeah. Like a little south of it, yeah.
What reason, Maddie?
Okay guys, try this one.
X minus 2 over x is equal to x minus 4. Oh, there's so many x's.
This is why she said it was wrong.
Who has this many x's, Jordan?
Hey guys,
Not quite.
this one works out nicer than you think as you're working through it, so
I'm not sure about that one.
something good happens. Oh, negative meeting. Good job, done it. Yes, good job. There's some foiling you have to do, but then some good stuff happens. Yes, good job. Both ways. Look at the 8. Oh, 2 times 6 is an 18. Yes, you're good. Yeah. Yeah. Those two together are -8.
Remember that?
Yes.
Easy.
Yes.
Easy.
How is
Not at
this?
all.
Yes, good job.
Three Carter X.
Yes.
You think the Saints are going to beat the Packers? No way.
Yes. Okay guys, I'm working up here if you're struggling. A few of you guys I saw just like silly mistakes when you distributed or multiplied. The good thing that happens in this case is the x squareds get to cancel. There's an x squared on each side, so they actually get to cancel out. We don't have to worry about factoring. X ends up being 3, and that's okay because it's not one of our excluded values.
I said I'm sorry, Maddie ran into you. I said sorry. So bad.
Do you ever say sorry to inanimate objects? Like you run into a desk, you're like, oh, sorry. Like,
My front door this morning, I was like, sorry.
It's always someone else.
all right.
Maddie's just clumsy like that. This.
Yes, Maddie. Yeah, you are. Yeah. Do not throw that at me. I won't.
Throw that Jordan. Put it in her butt. She's a good citizen. The Who's will be really happy.
All right. So here's a place where we can't do cross multiplying. So this is our second type. Is what happens when we don't have just a fraction on each side. So this is type 2. Type 2 diabetes. No.
Someone on the internet might get offended by that. what doesn't the internet get offended by these
Right.
days?
So more than one fraction on each side is the second type. So this is the case where we do want to figure out what the common denominator is, like you guys were trying to do for the warm-up question. However, rather than actually changing all the denominators, we're just going to use that common denominator to get rid of the fractions. So I'll write a little note and then I'll show you guys how to do that. So we're going to use the common denominator. I'm going to run out of room here. To eliminate the fractions or to cancel the fractions. To cancel the fractions. And there are other ways to do this. So like if you look online, you might see another method. And I'm not saying one's better than the other, or like maybe you'd even decide to combine those and then cross multiply. That works. There's lots of different ways to get this. So what is our common denominator between all of these? Yep.
Isn't the answer just 3 over 2?
The final answer?
That's a solid equation.
No, we're solving for x. We're solving for x.
Only
What's our common denominator? Yep.
16.
16. I think there's a smaller one.
8.
4.
4x.
Actually 4x, yeah. We need an x that's common, but also the 4. So our common denominator is 4x. Now, so that's the common number they can all become. Now, some of you guys said bigger common denominators, and those are okay. It's just better if it's smaller, and then we don't have to multiply more than once. Now, you can get all the denominators to be the same and then add them and work through this. I'm going to suggest you do something a little bit different. Is what we're going to do is we're going to multiply all the tops by this common denominator. So we're going to multiply each term by the common denominator. And if it helps to put the common denominator over 1. I'll show you how that looks. So our common denominator is 4x. So what I'm going to do is I'm going to multiply 4x to this first one. I probably should have made bigger spaces here. Let me rewrite this. Undo what I just did here. Oh goodness. All right. So I'm going to rewrite this problem, just give myself some more space. So 12 over x plus 3 over 4 equals 3 over 2. So what we're choosing to do is we're going to use this common denominator and multiply each fraction by it. So I'm going to multiply by 4x over 1. I'm going to multiply by 4x over 1. 4x over 1. As long as I'm multiplying everything by the same number, it's okay to do this. This is like an acceptable thing to do. What happens in the first fraction? The x's cancel. So there's no longer a fraction at all. What do I have? No, it's okay. 48. I have 12 times 4. So I have 48, but it's no longer a fraction. Plus. What happens in the second fraction? What cancels? The 4's. So what am I left with? 3x. No longer a fraction. How about the last one? You can simplify. The 4 over 2 becomes 2. So 3 times 2x is going to be
6x.
6x. But we just got rid of the fractions in that one step. Now this just becomes like an algebra equation that like my algebra students could solve because it's just, there's no longer any fractions in the problem. So what am I going to do now?
Subtract 3x.
3x. Then
Divide by 3.
divide by 3. So I find out x would be 16. Right?
So
Now, real quick, I guess I forgot at the start, the excluded value, the only thing we couldn't have would be 0 for x, so 16 is fine.
It's amazing.
Right? So let me show you guys that with a tougher problem. So the next one's a little bit tougher because it doesn't have as easy of a common denominator. Again, there are other methods out there. I'm not saying this is the only way, but if I showed you guys absolutely every method, we'd be kind of like, this would take a really long time. So we're gonna kind of just go with this method. If you like it, great. If not, you wanna try something different, that's fine. So what's our common denominator in this case? Careful. This one's a little bit tougher. Be the common denominator of everything. So what does this one need? X plus 2, but it also needs that 2. So it's basically like what every other one has. So the common denominator is 2 times x minus 1, x plus 2. This looks awful right now, but it's not going to be bad once we use it. The good part is the tops of these are all 1, which is kind of nice of them, or me, or whoever made this.
Probably you.
It was me, but I'm sure I stole it from somewhere.
No.
Okay. So I'm separating out this problem so I can show what I'm multiplying by. So each of these is going to be multiplied by that common denominator over 1. And we'll get to do some canceling then, once you have them written out. What cancels in that first fraction? The x minus 1. So what am I left with? 2 and then times x plus 2. If you wanted to multiply that right away, it's fine. We'll just wait. Plus, because the times 1 doesn't really anything happen. The next one, what cancels? The x plus 2's. We're left with 2 times x minus 1. And the last one, the 2's just cancel. So a whole lot cancels. We no longer have fractions, but now this becomes like a tougher algebra problem to solve. Not quite as straightforward as the other ones we've been doing. Or the ones like the one above. So over here I have to FOIL. So I'm going to move everything over to one side. It's a quadratic. now this should be factorable. I want to multiply to get -4, but add to get -3. -4 and 1.
Good job.
So my two answers then would be 4 and -1, right, when I set those each equal to 0. Now, do either of these get excluded? Careful.
Yeah. It's right there.
So -1 though, -1 would be -2. It's actually okay. I was just trying to be. So that's actually
Oh,
okay.
you're so silly.
I was just trying to like make you think. Oh.
Were we thinking this?
Yeah. Okay. All right. Questions there at all?
No.
So homework is listed there on the bottom. I know a few of you guys have stuff to finish for me, like either a test or you're working on corrections. Let me know. We can let you guys have time to work on that. If it's too loud in here and like to go next door to finish, you're welcome to.
It's the holidays.